derivative test for Extrema. I'll just show you the second derivative test because it involves second derivative, obviously, right? So, can you, somebody detail for us the first derivative test? How do we, just to summarize, what's the first derivative test?
It's on that side of the page.
Anybody? We just wrote a card for it. Wow. That's the informal name. How do you get there, Kristen?
You said f of x equal to 0.
Yeah, what?
That point? The prime of it?
Yeah, derivative, so. Okay, and solve, right?
Solve the critical points.
Yep. Okay, what do you do with the critical points?
Sign analysis. Plugging.
Yeah, you do sign analysis. Here's your critical point. So we have f prime at some value and f prime at another value, right? What if we have a negative and a positive here? Then, right? And a positive to a negative is a max. Okay. So that's the first derivative test. Okay. The second derivative test involves the same procedure here. It's going to be very common. Set f prime of x equals 0. But then beyond that, we're going to move to the second derivative and use concavity to test for min or max. Okay, so if we have a concave up shape at a critical point, is that a min or a max? That's a minimum, right? So we're going to use concavity to tell us whether we have a min or max. Okay. So that's second derivative test. All right, so make it fun. Anybody know what that looks like? No, me either. It's okay. Right. Okay, so the second derivative test, the first step is to calculate the derivative. Right. So f prime of x is?
dx. 2x. 2x. What's your copy? Is it a change?
What rule are we going to use? How are these connected? So that is a product rule, right? He started okay, it's fine. So derivative, then copy, right?
Yep.
So negative 2 minus 2x, copy u dx. So those can be switched. What he said was fine. Plus what?
Plus copy and then drag.
Copy and then drag. Okay. I can't believe they're interrupting calculus. Hello? Yeah. Okay, who are your kids? Anybody in ISS? Okay, oh, you got a class, that's right, okay. Okay, sounds good. Thanks. We're having issues.
Oh.
So what am I gonna write here? And the derivative of e to the x, right? Okay. We set that equal to 0, right? And solve for critical points. Okay, what's the first thing we try to do when we solve equation?
Well, no.
What do you
If it's a simple equation, you can, that's fine. Factor. If you can factor, that's what you do. Okay, so is there something here that I can factor out?
E to the x.
E to the x. So I'm left with 2 minus 2x. Plus 2x minus x squared, right?
Didn't you take a 2x out too, or is it?
Oh, because.
No, see, those are
Oh, okay.
subtracted, so.
That makes sense.
Now the 2x's would cancel out, right?
Oh, look at that. Looking a little easier this time.
What was that?
Okay, can e to the x ever equal 0?
No.
No, it does not. Okay, so we don't have to worry about that. Okay, so we need to worry about that one. What are my x values?
0. Or 2.
We're getting closer, but we're kind of bouncing around it.
Square root of 2.
2 equals x squared, right?
Yep. Plus one.
Positive or negative root 2 is x. Okay. Good. Okay, so that's, what would we could do the first derivative test now, correct? It would be easier, actually, right? But for the sake of showing you the second derivative test, we're going to move to that. Right, so we've simplified the derivative here, correct?
Yeah.
Yeah, so let's use that. Instead of that ugly monster up here. So what is the second derivative?
Is it still just a product?
Another product rule, yeah.
So,
E to the x.
you do that, and I copy 2 minus x squared plus e to the x
Times 2x.
times 2x. Negative 2x.
Thank you. Okay. We can make that easier by factoring again. Right, so you pull an e to the x out. 2 minus 2x minus x squared. If you want, you don't have to. Extend the page problem. Yeah. Okay. Now here's the key with the second derivative test. Analyze. Evaluate critical points in the second derivative. That'll tell us whether we're minimum or maximum. Right. So the second derivative at root 2 This is positive. And that's going to be 2 minus 2 is 0, correct? And then, so you get a negative here.
So that means it's going to become a negative.
So this is concave, down or up? You get negative in the second derivative. This is concave.
Down.
Negative. It's a negative second derivative. Yesterday we learned that's concave down.
Yeah.
We have a min or a max? Maximum. That's the second derivative test. Sometimes you are forced to use it. Okay. I'll kind of show you how that works. All right, and then do the second point. Probably gonna get a positive, huh? This is still positive. And that's gonna be a positive as well. So what's our conclusion? Yep, concave up,
Which is a min.
which would be a minimum.
Yes, it's positive.
They're long problems if you do the second derivative test all the way through. Good? So that, do you understand this conclusion? Take your critical values, critical points, plug them into the second derivative. Okay? And it tells you min or max. Are you clear that? Yes? Give me thumbs up or thumbs down, sideways. Sideways. Okay. There's one thing that this problem doesn't show you. Sometimes this will happen. If you're in your analysis step and you get the second derivative, it says 0, is that positive or negative? No, it's not. This is, so we are inconclusive. Okay, the second derivative test doesn't work sometimes. Bummer. We might have a fire alarm today, let's just be honest.
Oh, so that's what you're talking about?
Is that what they warned us about?
Why?
It's, the fire alarm's been on the fritz for about a week. You can ask your principals about having to come in over Thanksgiving break to deal with it.
That's fine.
All right, so that's the second derivative test. Most of the time on any test you get, it'll be calculate the extrema. So you'll probably use the first derivative test. Okay? But the only way that they will test you, or I will test you on the second derivative test, is I will force you to use it. Okay? So because these are so long, we don't want to do one of these in its entirety. So we would say, it might say something like calculate the extrema for f of x if f double prime of x is d dx times 2 minus 2x minus x squared with critical values. My handwriting is deteriorating.
Yep.
Honey, you're such a sweet person.
I'm in a hurry, apparently. So you're not even given f of x, you're given the second derivative and the critical points.
The same time?
Yeah. All you're doing is this step right here. At the bottom, right? fortunately, that you don't have to calculate the derivative or anything. You're given the critical values, plug them into the second derivative and see if you have min or max. Okay. That's mostly how it'll be done. Good. Questions? Do you want to see an example where the second derivative test is inconclusive? Okay. Sounds good. So if we're going to use the second derivative test, which we wouldn't, what's the derivative? Okay.
Can we take that in X squared?
You can do more than that even.
Oh, X squared?
You can do more than that even.
Five X cubed.
Yeah.
Or X squared, okay.
Greatest common factor, and then we end up with an x minus 4. Yeah? So our values are 0 and 4. Those are our critical points. Second derivative is? X cubed minus 60x squared, right? That is awful. What do we do with that? Plug those. Yeah, so f total prime at 0 is? 0. Ooh, bummer. See how that's not positive or negative?
Yep.
It tells us nothing. Okay, so we are inconclusive.
Could you still factor it
Yeah,
out?
and then plug 4 in.
No, negative. Right? Yeah, because you have
64 times 20 is 1280.
Yeah.
And 60 times 16.
That's less, way less. So it would be positive.
That's less, yes, this is positive. What does that tell us?
to see if you want up, concave up.
Concave up? Here's the minimum.
Do you have to draw a handle from here?
No, you don't have to. You don't have to do this. It's just fun to have some problem stickers coming out of you. Okay, there you go. Yeah, we're back in 5th grade now, apparently. Okay, so what do we do at this point? You can't throw nothing away. Well done.
I don't know.
How would you attack a min-max problem? Before today, how would you have done that problem?
Do it with the first derivative.
First derivative test. Yeah, try another test. Okay. So if this is inconclusive, try another method.
So would you, okay, if you try another method, would you still have to do it for the other critical point?
You don't have to know, you know the answer to this one. Yeah, so if you want, you can try the first derivative test
What you gonna complete, just the zero.
0. And remember, you're now in the first derivative. Okay. So, like I said, you won't probably have to deal with this situation, but it's a possibility. I don't want to leave you hanging. All right. So, if I plug -1 into the first derivative, I get a negative and a negative, which makes a positive. And here I get a positive and a negative, which means I have a maximum. Much easier, right? First derivative test?
Yep.
It is. So if you ever get the chance to use the first derivative test, unless you are forced to use the second derivative test, in which case they make it pretty straightforward with this. All right?
Is it ever easier to use the second derivative?
Well, yeah, and then probably not if you have an option. You know, sit through 100 problems probably to find one. But okay, good. Question? I gave you the homework yesterday. Do you want me to write it down again?
No.
Okay, we're good then. Let's do tomorrow with